Okay, 2.1. 2.1 deals with functions and domain and ranges of functions, or just domain and range in general. So the first thing we have to do here is um, we're going to identify what is called a relation between input values and output values. Now, a relation is anything that you can graph. So, like our ordered pairs are going to be are going to be now called relation. That's what we're going to try to call them from here on out in Algebra 2. And then we have to look at what's called function notation. And you may have seen this before in Algebra 1. Instead of putting a y equals 3x plus 4, we're going to use the way you pronounce this is the f of x. So this is a function with respect to x. Now you can use any variable that you want, whether it's the f of h, then you would have 3h plus 4, but it's whatever variable um, for that function. So in this function, we have x, and what we're going to do is when we put a value for that x in that notation, you want us to substitute in that value for x. So the input value here would be 5. And the output value then would be, well, we have to compute that. So when we have the f of x equals 3, and I'm going to substitute in that 5 for x, and then I'm going to add 4. And my x was 5. So I go ahead and compute that, and I get 3 times 5 is 15 plus 4. So my output value then would be 19. Okay, again, let's do some vocabulary. This section is going to be a little heavy on vocabulary. The relation is, as I said earlier, a relation is any set of ordered pairs. And in Algebra 2 and Algebra 1, you use the Cartesian graph for this ordered pair, an x and a y. Now, the domain is a set of all the x values. Which makes the range the set of all the y values. And the term function, the definition of a function is for every input, there's exactly one output. So in our English terms, for every, let's write, for every x value, um, let's just say every x value has only one y value. Try to make it as easy as we can for us. Okay, so let's look at an example of some of this terminology here. And looking at example 1, we have a chart, a visual chart of ordered pairs. Well, remember, we're not going to call them any from this point on. We'll try, and again, I keep calling them ordered pairs all the time. Let's try and use our relation here. So I have a relation between some numbers, and it happens to be an ordered pair. Now, remember, these are our input values and our output values. So I'm going to go ahead and graph those on the Cartesian plane. So I have 2, 4, -1, 3, 2, 6, and 0, 2. Okay. Now, don't draw a line here because this is not a continuous relation or a continuous function. It's just a set of x and y values. So don't put a line there. Now, is this a function? Well, no, because we have an issue here. See this 2? My x, I have 2 here and here, and they have 2 different y values. Remember, every x has to have only one y value. So here, it is not a function because the x value 2 has 2, I gotta write out the word 2, y values. Not a function. Okay, now I'm gonna have to go ahead and write the domain and range here. Now, the domain, again, remember it's the set, it's all the y values, and this time it's just points here. So I'm going to use what are called set. They're those the set braces, or it's those curly Q things. And it's going to have the set of numbers. And normally we put them from lowest to highest. So I have the set -1. I'm looking at my x values. 0 would be the next one. And 2, even though 2 is here twice, I'm just going to put it in my set notation here once. My range is going to be my y values. So it's a set of numbers. And again, from lowest to highest, I have 2, 3, 4, and 6. And that's it. That's all they're asking for. So I'm done with that example. For this example 2, again, here I have a relation. And here's my order of pairs. 3, 4, -3, 3, 2, 4, and 0, 5. Now, look here and see that I have a different value of y for each one of my x's. So this is indeed a function. Because every x only has one y value. Now, I know some of you are getting confused right now and saying, hey, wait a minute. Wait a minute, Mr. D. There's a 4 here and a 4 here. Yeah, but this is the y value. It's okay to have the same y value. Up here, notice the difference. This was the same x value. Having the same y value, as long as the x values are different, we're okay. X values, or I'm sorry, Y values can repeat. X values cannot. So the domain for this, it's the set of numbers. Let's put them in numerical order. -3. Let's see, 0, 2, and then +3. And then for my range, I have the set of numbers 3, 4, don't need to put on a second 4, and 5. That's the worst curly bracket I ever made. All right, now there is what's called a vertical line test to determine whether relations are functions. Okay, this comes in real handy, especially when we start looking at the continuous functions on the back. Now, a lot of times they're going to a lot of standardized tests and even some tests that we give on quizzes and Delta Math. They're going to want you to go ahead and fill out some examples of what is a function and what is not. So I'm going to do some examples of what a function is and what a function is not. In fact, I'm going to do 3 examples. Okay, the easiest one to determine that shows up as a function is a line. Just about any line is a function. Okay. Now, there is one line that is not a function. I'll get to that in a minute. So what we do is we go ahead and test to see if it's a function using a vertical line test. So I go ahead and put vertical lines in there, or I could just look at my ruler and see if a vertical line will intersect this graph at more than one point. And of course, this line is a function, so it only intersects at one point. That's okay. It passes the vertical line test. So yes, this is a function. Well, what about something like a parabola? Is that a function? Now remember, these kind of drift off on an angle out to infinity. So they're kind of going on an angle. So if I take my vertical line and go ahead and draw some, or just use the ruler itself, it only intersects the graph at one point. So again, this passes the vertical line test. So this is a function. And then lastly, when you get into higher mathematics, you'll find out that these parabolas sometimes turn sideways. Okay, so now if I use my vertical line test, I notice that it intersects at 2 points. So this is not a function. Fails a vertical line test. Okay. Now let's look at some continuous functions where we have where we go ahead and put lines in between our points. Okay, this is called a continuous function. Now, what we have to do is come up with the domain and the range and tell us if it is a function. So the domain, let's talk about a little bit about the domain. If you remember, the domain are all the x values. Okay? And we read, so the domain, I'm looking at the x-axis, the domain is going to go from left to right, like the way we read. So if I'm looking at this continuous function, this relation, I'm going to look at those x values. So I'm looking at the x-axis. So I'm looking here, and it starts at 6. I'm sorry, -6. And if you notice, it's got a solid dot there. So I'm going to use a bracket to include the -6. And then it stops at +6. And again, it's got the closed circle, so I'm going to use a bracket. Now the range is going to go from lowest to highest. So looking at my relation here, my lowest point, this one's going to be the lowest point, and it starts on my y at -3. And again, it's got that closed circle. So it's going to have the bracket. And I know it goes here, it goes up, my relation goes up, goes down, but at the peak, it's at my highest, my range is 4. And then to tell whether it's a function or not, well, I'm going to go ahead and do my vertical line test. Notice that it only crosses at one point. So yes, this is a function because passes vertical line test. Yes, you can abbreviate. Okay, number 4. And here's my domain. Goes from left to right. Range, lowest to highest. So my domain for this continuous function, or relation, I should say relation. It's not a function. This is just a relation. Continuous relation. So I'm looking at my domain. And let's see. Looks like here at -4 includes -4. And here at +8, range, let's see, I know it kind of dips below -4, but we're going to keep it whole numbers here. -4 and +1. Graphs a little off, that's all. Vertical line test. And you notice it fails immediately because it intersects at 2 points. No, fails, vertical line test. Number 5. Now, you got to keep in mind that this relation, these go out forever and ever. Okay, so our domain, wow, if these go out forever and ever, and go from -infinity and it stops at 3 and includes 3. Now remember, I've talked about infinity. It could never include infinity, so infinities always get parentheses. Okay, so let's look at our range. our range, the lowest, again, this is going towards negative infinity. And this is going up towards positive infinity. Parentheses. Is it a function? I can tell you right away it's not. Because if I put a vertical line in here, and we did this on the front, it is not a function. And lastly, let's see, here's my domain. Here's my range. Okay. And again, this is going to go out to infinity. This time, my domain is going to be from negative infinity to positive infinity. My range, lowest point, is right here. Be careful, it's not 2. It's the y value here. So 0 includes that point 0 here. And then it goes up to positive infinity. Is it a function? Yep. Only intersects at one point. And that's it for 2.1.